The Binomial Theorem. First, a little warm-up, applying Pascal's formula to combinations. We're just going to rewrite each of the following using Pascal's formula. So 12C8 equals 11C7 plus 11C8. 19C5 plus 19C6 would equal the next row, 20C6. The binomial theorem. So a plus b all squared equals the actual theorem using combinations. In this case, n would equal 2, and you can replace n with 2, replace r with 0, 2 minus 0, and 0. And it is the sum starting at 2 and running all the way down to 0. And now an example of applying the binomial theorem using combinations to expand. So the summation sign, we're starting at 6 because that is the exponent, and we're going all the way down to 0. We have our choose, and we're indicating we're starting again at 6 and going down to r, which in this case is 0. So it's easier just to write it out as I explain this. So this becomes 6 choose 0. Then we'll do 6 choose 1. And then we'll do 6 choose 2. 6 choose 3. 6 choose 4. 6 choose 5. And 6 choose 6. So I'm writing out the 6th row of the Pascal's triangle. And so now we'll deal with a and b. So it's a to the 6, b to the 0, a to the 5, b to the 1, a4, b2, a3, b3, a2, b4, a1, b5, and a0, b6. So I'm hoping you can see that the A's start at 6 and work their way down to 0. And the B's start at 0 and go the opposite way. All right, so now I'm going to tidy up the equation here and solve it. So this is a to the 6th, because C choose 0 is 1, and b to the 0 is also 1. And then C choose 1 is 6. So we have 6, a, 5, b. I'll just continue. So 15, a4, b squared, 20, a3, b3, 15 again, a2, b4, and then down to 6, a1, b5, and lastly 1b to the 6th. And there's a 1 in front of that a as well. So a couple things I wouldn't normally do, but I'm just showing you that each one of these choose in front of the variables becomes a number in the 6th row of Pascal's triangle from which choose derives. So we've got 1, 6, 15, 20, 15, 6, 1. That is the 6th row. And now to tidy it up perfectly, this would become a6 plus 15, a4, b squared, a squared, b4, And now 6a, and I've got a couple of b's there for some reason. Don't need that. So it's 6a to the 1, b5 plus b to the 6th. Okay, so that is the binomial theorem linked up with combinations to expand and using the sigma formation. It's derived from the 6th row of Pascal's triangle. And now we're going to use Pascal's triangle to expand each of the examples that you see on the screen. Since the exponent is 4, I know that the coefficients will be 1, 4, 6, 4, and 1. So my first term is going to be 1 times 2x to the 4, negative 1 to the 0. Notice that 4 and 0 add up to 1. The second term is going to start with a 4, and then it's 2x cubed, negative 1 to the 1, and again those exponents add up to 4. Then it's 6, 2x squared, negative 1 squared, back to 4, 2x to the 1, negative 1 cubed, and then back to 1, 2x to the 0, negative 1 to the 4. So as you're doing this, once you're comfortable and you're comfortable with exponents, this is unnecessary because we know that that's 1. The exponent of 1 is unnecessary. And this would be unnecessary because we know that's 1. Okay, so now tidying it up to solve it, this would become 16x to the 4th minus 32x cubed plus 24x squared minus 8x plus 1. Okay, the second example, we've got the 5th row of Pascal's triangle, so our coefficients will be 1, 5, 10, 10, 5, and then 1. Notice that when the exponent is 5, we have 6 terms, and in our first example, the exponent was 4, and we end up with 5 terms. So much the same way here, using the coefficients to start. The first term starts with the exponent given, which is 5. The second term starts from 0. And then we just continue on adding the numbers of the 5th row of Pascal's triangle. The first term goes from 5 to 4. The second term goes from 0 to 1. Four becomes 3. 1 becomes 2. 3 becomes 2. 2 becomes 3. I'll use another line so I can stay on the screen. Coefficient is now 5. First term exponent is now 1. Second term becomes 4. And now we're at the end. First term is 0. And the last term is 5. And then it's a matter of multiplying out, and that will become 243 x to the 5th, 810 x4y, 1050, I believe, 1080, x3y squared, 720 x squared y cubed, 240 x y to the 4th, and lastly 32y to the fifth. And there you have it, using Pascal's triangle to expand. And now we'll turn to the binomial theorem to expand and simplify. So we have the summation sign. We're starting at 4 and we're going all the way down to 0. So it's 4 choose R. And the first term starts at 4. And the second term is going to start at 0. Okay, so I'm going to try to be neat here. So 4, choose 0. X to the 4, 2x squared to the 0. That's our first term. 4 choose 1, x cubed. The second term increases from 0 to 1. Third term, 4 choose 2, x squared. And we move from 1 to 2 in the second term. 4 choose 3, x to the 1. 2 moves to 3, and now our last term, x to the 0, 2x squared, and our last term hits the 4. So once you see it, I'm going to highlight again how this works. Your first term starts at 4 and moves all the way down to 0. Your second term starts at 0 and moves all the way up to 1, which is the exponent value. Sorry, up to 4. Okay, so now I'm going to realize that it's the fourth row of Pascal's triangle, so that's 1, 4, 6, 4, 1. The first term becomes x to the 4, because anything to the exponent 0 is 1. So I suppose I could do this to look after each one of those. 4 choose 1 is 4. I've got the x cubed. And then I've got 2 over x squared. Just going to zoom in to give myself some space. So 4 choose 2 is 6. And I have got 6x squared now. So 2 squared is 4. And x squared squared is x to the 4th. Okay, 4 choose 3 is 4. X to the 1 is x. 2 cubed is 8. X squared cubed is x to the 6. And then plus 1. X to the 0 is 1. 2 to the 4th is 16. And x squared to the 4th is x to the 8th. And lastly, that will become x4 plus 8x cubed. Oh, it's actually, that's not true. It's just 8x plus 24x negative 2, 32x negative 6, 16x negative 8. And there it is, using the binomial theorem and the summation sign. And now let's use our knowledge of Pascal's triangle to write each of the following in combination form. So the sum of the terms in row 5 and 6, well, row 5, the sum of those is 2 to the 5th, which is 32. So that's row 5. And row 6 would be 2 to the 6, which is 64. Letter B. The sum of the terms in row n. So it's the nth row. Therefore, it would be 2 to whatever n happens to be. Letter C, the first 5 triangular numbers. Okay, so and again, we're going to use Pascal's triangle to write this. So the first 5 triangular numbers. So the number 1, okay, the actual triangular number here. So it will be 1, 3, 6, 10, and 15. The combination value of that would be 2C2, 3C2, 4C2. So it's the second term in each of the rows. And that's hooking up the first triangular numbers to Pascal's triangle. And lastly, the nth triangular number would be n plus 1, and then the second term. And my last example is factoring. So far we've been expanding and simplifying, and now we'll do the opposite operation, which is factoring. I made a typo, which is the great big black line there, so I've written out the correct expression there for us to factor. So we're going to move backwards. We've got 1, 2, 3, 4, 5, 6 terms. So if we have 6 terms, that means the exponent would have to be 5. So the exponent value is 5. Now we have to find our 2 values to create the binomial. So the first term is 1, and the first term would have to be a to the exponent of n. So if the value is 1, that means that a would have to equal 1, because 1 to the 5th is 1. So we have our first term looked after. B is the last term. The last term is 32x to the 10. And so if you look at it from the perspective of the exponent being 5, then that term of b would have to be 2x squared. And there we have it. So it's just working backwards. Hope that was useful. Thanks for listening.